ഹലോ എവ്രി വൺ, വെൽക്കം ടു വിന്നേഴ്സ് ക്ലാസ് റൂം. ഞാൻ രമ്യ. വിന്നേഴ്സ് ക്ലാസ് റൂം എന്ന ചാനലിലെ ക്ലാസ്സുകൾ നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ഈ ചാനൽ സബ്സ്ക്രൈബ് ചെയ്യുന്നതിനെ സപ്പോർട്ട് ചെയ്യുക. അതുപോലെ ഈ ക്ലാസ് നിങ്ങൾക്ക് ഇഷ്ടപ്പെടുന്നെങ്കിൽ ലൈക്ക് ചെയ്യാനും ഷെയർ ചെയ്യാനും മറക്കരുത്. Now we are going to learn about periodic classification of elements. Okay, we all know that there are 118 elements, out of which 94 are natural elements. Okay, as far as we know, Lavoisier was the first one who tried to classify these elements, but only 30 elements were known by that time. So he classified them according to their properties as acids and bases. But we know some elements do not belong to these two classifications, right? Thus, that mode of classification was not perfect. Then comes Dobrino's triads. Okay, 3 elements having similar properties were grouped in this mode of classification. Elements were arranged according to the increasing order of atomic mass. These groups were called triads. Suppose x1, x2, x3 forms a triad, then atomic mass of the middle one, x2, the atomic mass of the middle one in a triad is equal to or approximately equal to the arithmetic mean of atomic masses of the first one and the third one. Okay, in a triad there will be 3 elements. The atomic mass of the middle one, see, these 3 elements are arranged in the increasing order of their atomic masses. Okay, so the atomic mass of the middle one will be the average or the arithmetic mean of atomic masses of the first one and the third one. That is represented here. Okay, now triads. Some examples are here: lithium, sodium, potassium. We know all these 3 have similar properties. Then nitrogen, phosphorus, arsenic. Okay, then calcium, strontium and barium. Sr stands for strontium. Then chlorine, bromium, iodine. Like this, who made Dobrino made this mode of classification known as triads. Now let us check which were the limitations of Dobrino's classification. All the non-elements were not be able to get arranged as triads. All the elements which were known by that time were not good to be arranged as triads. Dobrino could identify only 3 triads of elements. Only 3 triads were classified perfectly. Then came Newlands Law of Octaves. Newlands found that if the elements were arranged in the order of their increasing atomic masses, the eighth element starting from the given one repeats the properties of the first. See, here a group is given: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Then sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine. Then potassium, calcium. See, here 7 elements are here. The 8th one repeats the properties of the first one. This is the first one. Here comes the 7th one. This is the 8th one. 8th one repeats the properties of the first one. Okay, we know lithium and sodium have similar properties. So Dobrino's triads also existed in the columns of Newlands classification of elements. This is Newlands classification of elements. See here, lithium, sodium, potassium. This was there in Dobrino's triads also. So Dobrino's triads also existed in the columns of Newlands classification of elements. Now let us check which were the limitations of Newlands Law of Octaves. Only 56 elements were known at the time of Newlands, and only elements up to calcium with atomic mass 40 could be fitted in octaves. See, just 56 elements were known at that time, and out of that also only up to 40 calcium, only up to calcium could be fitted in octaves. This classification was applicable only for lighter elements. See, octaves was not possible. This mode of classification was not possible for high atomic mass elements. In order to fit elements into his table, Newlands adjusted 2 elements in the same slot. See, cobalt and nickel. Cobalt and nickel were in the same slot in Newlands octaves. Cobalt and nickel were in the same slot, but this slot was in the column of fluorine, chlorine and bromium, which have different properties. We know these 3 elements differ from cobalt and nickel, but in Newlands method, Newlands octaves, these were in the same column, okay, which have different properties. At the same time, iron, Fe iron, which resembles cobalt and nickel, was placed far away from cobalt and nickel. Okay, these were the limitations. When noble gases were discovered, see, at that time when Newlands octaves came into practice, noble gases were not there, but when noble gases were discovered, the similarity of properties of elements got repeated after 8th element only. See, actually in octaves, after each 7th element, see, after each 7th element, the similarity repeats. But here, see, there is no noble gases here. When noble gases came, the repetition of similarity occurs after the 8th element only. These are the limitations of Newlands octaves method.